p.222 number 103, solve the logarithmic equation algebraically. And we're given the natural log of x plus 5 equals the natural log of x minus 1 minus the natural log of x plus 1. Okay, we've got our work cut out for us here. First of all, let's take a look at these two natural logarithms subtracted. Now, we have a property that says if we subtract two separate logarithms, we can rewrite this as one logarithm with the quantities divided. So let me just bring down this first part. Natural log of x plus 5 equals, this is going to be one logarithm with those two quantities divided. Natural log of x minus 1 over x plus 1. Okay, now let's take a look at this. We have the natural log of something equals the natural log of something else. Well, those amounts must be the same. Natural log of this amount equals natural log of this amount. So let's write our equation this way. This first amount, x plus 5, must be equal to this second amount, x minus 1, divided by x plus 1. Okay, now let's solve this for x. First of all, I don't like this fraction here, so I'm going to multiply both sides by x plus 1. On the right, it'll just cancel out the x plus 1 that we have. On the left, it's going to turn into a FOIL problem. Okay, we can handle this. First outer inner last gives us x squared plus 1x plus 5x, which we'll write as plus 6x plus 5 equals x minus 1. Now to solve this, we're going to have to get all of our terms on the same side of the equal sign, set it equal to 0, and then try to factor. So I'm going to subtract x from both sides. Then I'm going to add 1 to both sides. That will give me x squared plus 5x plus 6 is equal to 0. Now let's factor this expression. Factoring this gives me x plus 3 times x plus 2 equals 0. If I set each of these equal to 0, I'll get two solutions here. X equals negative 3 and x equals negative 2. Now we have to be especially cautious with these negative solutions. Let's try plugging these in here. If I plug a number like negative 3 in, that'll give me the natural log of negative 3 plus 5, which is 2. That's okay. But negative 3 minus 1 is negative 4. I can't take the logarithm of a negative quantity. So whether I plug negative 3 or negative 2 in here, I'll have a negative quantity. That means that although these numbers worked algebraically, when I plug them back in, they don't work in this equation. So there is no number that works. So my answer here is no solution.